Look around. Everything you see, every star, every planet, every galaxy is part of a vast cosmic symphony. But today, we're stepping beyond that familiar stage and into the uncharted fringes of reality itself. Welcome, fellow cosmic travelers, to the edge of the believable, where science itself blurs into the surreal. Let's dive headfirst into anomalies so strange, so astonishing. They challenge the very foundations of our understanding of the universe. Imagine first something known as the Booty's Void, an eerie cosmic emptiness so vast it defies logic. Picture this: a region of space nearly 330 million light-years across. That's right, 330 million. Within this incomprehensibly huge void, there are just a handful of galaxies scattered like tiny islands, lost in an endless ocean of nothingness. To give you perspective, if our Milky Way sat at the center of the Booty's Void, it would have taken centuries for our telescopes to spot even one neighboring galaxy. Scientists remain baffled. What cosmic event created this vast emptiness? What powerful forces were at play? These questions still echo through the halls of astrophysics labs worldwide. Now let's swing our telescope toward an equally perplexing mystery: fast radio bursts, or FRBS. Imagine signals arriving from distant galaxies, intense bursts of radio waves lasting mere milliseconds. Blink and you'd miss them. But the energy released is equal to millions of stars exploding simultaneously. Where do these signals originate? Aliens sending us messages? Stellar collisions? Or perhaps something stranger still, like neutron stars screaming their final cosmic breaths? Astronomers are on the edge of their seats, racing to decode these enigmatic pulses from across the cosmos. From pulsating signals, let's turn to hypervelocity stars, rogue suns hurled across the galaxy at mind-boggling speeds. Imagine a star, millions of times the mass of Earth, traveling at millions of miles per hour, so fast it can escape the gravity of our Milky Way itself. What propels these stellar nomads to such extremes? Usually, it's a close encounter with a supermassive black hole, violently flinging them outward in a gravitational slingshot maneuver. Think about it. Right now, somewhere out there, entire stars are hurtling through the darkness of space, doomed to wander alone until their fiery deaths. Speaking of black holes, let's talk about perhaps the strangest anomaly of them all: white holes. Theoretically predicted by Einstein's equations, these bizarre objects are essentially the opposite of black holes, spewing out matter and energy rather than sucking them in. Imagine a cosmic fountain pouring matter into our universe from elsewhere. Could it be a gateway to another dimension, another universe? While we've yet to detect one conclusively, physicists eagerly chase the ghostly evidence, hopeful that one day white holes might unveil deeper truths hidden beyond our wildest imaginations. Now hold on to your seats, because we're headed to the coldest spot in space. We're talking about the cold spot in the cosmic microwave background radiation, a colossal region, roughly 1 billion light-years wide, that's mysteriously colder than the rest of the observable universe. Scientists are puzzled. What could cause such a vast temperature difference on cosmic scales? Is it evidence of another universe brushing against ours, creating an immense cosmic bruise? Or perhaps it's just a fluke, a statistical anomaly challenging our most sacred cosmological theories. One thing's for sure: this frigid mystery chills scientists to their bones. And what about the bizarre star, known simply as Tabby's star? Imagine watching a star suddenly dimming dramatically without any clear reason. Is it a swarm of comets passing by? cosmic dust clouds, or maybe, just maybe, an advanced alien civilization building something colossal, like a Dyson sphere, around their sun. Astronomers scratch their heads, telescopes glued to the sky, waiting for the next drop in brightness. The mystery deepens with every observation, pushing the imagination and science to their absolute limits. But if that wasn't enough, brace yourself for gravitational anomalies, strange places where gravity doesn't behave quite as expected. Imagine regions in space where matter seems to be influenced by unseen forces, bending light in ways that defy predictions. Astronomers use gravitational lensing to spot these mysterious invisible structures, suspecting they're vast clusters of dark matter, an elusive cosmic component making up over a quarter of our universe, yet remaining entirely invisible. It's the universe's greatest magic trick, dark matter pulling strings from behind the curtain, shaping galaxies, guiding cosmic evolution, yet evading all direct detection. Finally, we journey to one of the greatest mysteries, the axis of evil. Yes, you heard right. Cosmologists humorously dubbed this anomaly due to its troubling implications. The cosmic microwave background, the echo from the birth of the universe itself, unexpectedly aligns itself along a specific cosmic axis. It hints that the universe may have a preferred direction, which would shake the very core of cosmology, challenging our assumption that the cosmos is isotropic, equal in all directions. Is this cosmic alignment mere coincidence, or a hint that reality itself is structured in ways we've yet to fathom? These anomalies, these cosmic oddities, force us to reconsider everything. They're reminders that despite our impressive technological achievements, despite our intricate equations and theories, we remain humble explorers, sailing into unknown waters beneath a sky filled with mysteries yet to be solved. Out there, beyond the comfort of our daily lives and our tidy explanations, lies an ocean of mysteries, waiting patiently for our attention. Consider neutron stars, stellar corpses so dense that a mere teaspoonful of their material weighs as much as a mountain. But among these strange celestial bodies are pulsars spinning hundreds of times per second, flashing beams of radiation like cosmic lighthouses guiding us through the unknown. Imagine it, a star-sized object rotating faster than a kitchen blender. Physics stretched to breaking point, yet somehow holding steady. Journey further into strangeness, and you'll encounter magnetars, neutron stars on steroids. These stellar giants boast magnetic fields billions of times stronger than Earth's, powerful enough to strip atoms apart from thousands of kilometers away. Even from halfway across the galaxy, a magnetar's sudden eruption can blast Earth with X-rays intense enough to briefly disrupt our satellite communications. Think about it. Cosmic tantrums capable of affecting our modern technological world, despite originating thousands of light years away. If neutron stars seem extreme, try this cosmic oddity on for size: quark stars. Hypothetical objects so dense, neutrons themselves disintegrate under extreme pressures, giving rise to a sea of quarks, the fundamental particles making up all matter. It's as though nature tears down its own rules, allowing bizarre forms of matter to exist right under our cosmic noses. Though purely theoretical, quark stars could redefine our entire understanding of stellar evolution, potentially hiding in plain sight within neutron star disguises. But let's not neglect the phenomenon of gravitational waves, ripples in space-time itself. Einstein predicted them, but it took humanity nearly a century to directly detect these elusive distortions. Generated by cataclysmic cosmic events, like the merging of black holes billions of years ago, These waves ripple across billions of miles, quietly whispering the universe's most dramatic secrets. Every gravitational wave detected carries stories from the farthest corners of reality, allowing us to hear cosmic symphonies otherwise invisible and silent to traditional telescopes. Now consider the phenomenon known as dark flow, a mysterious observation indicating galaxy clusters moving toward an unknown gravitational attractor lurking far beyond the observable universe. Imagine entire groups of galaxies, billions of stars strong, drifting like leaves caught in a hidden cosmic current. Could there be massive structures beyond our horizon influencing the observable universe? Or is this phenomenon a hint of hidden dimensions, pulling strings from just beyond our cosmic sightline? Speaking of dimensions, let's dive even deeper into the unknown, parallel universes. Some scientists speculate that every decision we make, every quantum fluctuation, creates branching universes, a multiverse sprawling infinitely in all directions. Sounds like science fiction? Perhaps. Yet quantum mechanics and cosmology continually dance on this edge, flirting with realities far stranger than fiction itself. Imagine infinite versions of you, each living a slightly different life, scattered across countless parallel universes. Science boldly stepping where imagination once exclusively roamed. And if infinite worlds weren't enough to ponder, there's the baffling quantum entanglement, Einstein's famous spooky action at a distance. Picture two particles linked instantly, regardless of the distance separating them, communicating faster than the speed of light. Quantum entanglement teases a reality where space and distance become illusions, challenging our intuitive understanding of the universe, whispering softly to physicists that reality may not be what it seems at all. Our cosmos doesn't just hold secrets, it actively beckons us, inviting us deeper into realms that defy comprehension, forcing us to ask profound questions about existence itself. With every discovery, we're reminded that science isn't simply about finding answers, but about discovering better, more intriguing questions that lead us ever further toward the very edge of reality. This is Whispers of the Cosmos.